Very good morning to all students. Today we will discuss about the chapter 1, class 12, chapter 1 solution. We know why this is very important chapter for the board level as well as the competition NEET JEE level. We will discuss mainly about the types of solutions, what are the different types of solutions, binary solutions means two component solutions, concentrations means different stages of the solutions. Here after that we will discuss about the solubility, then we will discuss about the Henry's law and Raoult's law. Here also we will discuss about the ideal solutions, non-ideal solutions. Also we will discuss about the colligative properties. The most important part of this chapter is the colligative properties. Colligative properties we learn that it is the property which depends on the number of particles and not the nature of particles. And after that there are some components when dissolved in water they dissociates, some they associates. That means number of particle changes, and we will discuss about the abnormal colligative properties, that is called the Van 't Hoff factors, and we use the different numerical expressions over here, and then we will do the numericals. This is our total contents in these chapters. Now let's discuss about that portions. So chapter solution, already I have told you that here we will discuss about the basic definitions and types of solutions, methods of expressing the strength of solution, that is the concentrations, the solubility and the Henry's law. Henry's law we will discuss. Okay, vapor pressure of the solution. Most important part related to this chapter is the vapor pressure. What is vapor pressure, that also we will discuss. Colligative properties, what is colligative properties, and here we will discuss about the ideal solution, non-ideal solution and Raoult's law. Then we will discuss about the Van 't Hoff factor. I told you the abnormal molecular mass, Van 't Hoff factor denoted by I, and then formula chart, what are the formula we have, and numerical problems. Now you see in these chapters already told you the liquid solution and the formations, how the different types of solution, gas solution, solid liquid solutions, okay, solid solution, liquid solutions, how it is formed with the example we will discuss. That we know basic part we have learned in class 9 level, 8 level, okay. Still we have over here, and then the most important part is the vapor pressure and colligative property. Vapor pressure and colligative properties. Vapor pressure I told you details later on. So what is vapor pressures? Pressure exerted by the vapor when the vapor is in equilibrium with the solutions in a closed component. So when the closed component is possible, then the equilibrium is possible. If you keep any solution is open, it will vaporize, it will not be in equilibrium states. When the pressure exerted by the vapor, when the vapor is in equilibrium with the solution, then the pressure is called the vapor pressure. We will discuss later on. And colligative property, I told you, the property which depends on the number of particles. Number of particles, not the nature of particles. Whether the glucose, sucrose, whether the sodium chloride, doesn't matter. It depends on the number. How many numbers? 1 mole, 2 mole. Okay. So that depends on the number of particles, and that is the colligative property. We'll begin with some important basic definitions. We know the types of solution, expressing the concentration of solution. Different concentrate we'll discuss. We'll discuss about the mass percentage, weight by weight percentage, weight by volume percentage, volume by volume percentage. Then we will discuss about the molarity, then we will discuss about the molality, then we will discuss about the normality and the relations of there. Okay. So relation is very, very important. What is the difference between the relation between the normality and molarity? What is the relation between the density, molarity? What is the relation between the molality and mole fraction? There is another term is mole fraction, very important part. Okay. So that we will discuss in the concentration terms. Okay, thereafter we will state and explain the Henry's law and Raoult's law, distinguish between the ideal and non-ideal solutions. Here is very important. Ideal solution, what is the ideal solutions? Okay, what is the non-ideal solution? So a very important part over here. Like say when 20 cc methyl alcohol, 20 cc water is mixed, we'll get the 40 cc. Obviously 20, 20, 40. But when we'll mix 20 cc, 20 cc, we think that it should be 40, but actually it will not be 40. In case of ideal solution, 20 cc and 20 cc will be 40 cc. If it is non-ideal solution, it will not be the 40 cc. Either it will be less or it will be the more. If it is non-ideal, positive deviation and negative deviation is there. So that we'll discuss over here. Like say 20 cc methyl benzene and 20 cc toluene, it is ideal solution. Here it will be 20 will be 40 cc. But I have given the example 20 cc methyl alcohol, 20 cc water, it should be 40 cc. It will not be the 40 cc. Okay, so that we will discuss in the non-ideal solution. So very, very important part, ideal solution and non-ideal solution. We will continue with that. And the deviation from the Raoult's law we will discuss, and the abnormal colligative properties. Okay, and when the molecule associate or dissociates, like say when acetic acid keep concentrated acetic acid, what happens? Two molecules join together and it dimerizes. Molecule may be the trimerizes. That means two molecule acetic acid forms one molecule. That means two molecule associate, to the number of moles decreases. Okay, dimerizes, and that is the association. Then we will use the Van der factor. And when the molecules sodium chloride, 1 mole if we give in solution, it will give the 2 mole. 1 mole NaCl will give the 2 mole Na plus. Okay, 2 mole it will give. That means 2 Na plus and 2 Cl minus. Okay, so 2 Na, 1 mole NaCl, it will give the 1 mole Na plus 1 mole Cl. That means it is coming the 2 moles. That means when the molecules are ionic compounds, then they dissociate to give the defined moles. Like say barium nitrate, 1 mole it will give the 3 moles. Okay, potassium ferrocyanide, 1 mole it will give the 5 moles. Aluminum sulfate is Al2SO4 whole thrice. Okay, so 1 mole it will give the 2 and 3, that means 5 moles. Okay, that the number of moles will change and colligative property will changes, and that is the dissociation. And then we will use the Van der factor. Now you see some important definitions are there. We know this is the basic definition you have learned in the class 8, 9 level. Okay, still it is required. Okay, so you know the mixtures, it is homogeneous mixtures. We know it is the homogeneous mixtures. Okay, mixtures are two types, homogeneous and heterogeneous. Okay, so when two or more chemically non-reacting substances are mixed, they form the mixtures, that we know. Okay, one is heterogeneous mixtures. They are not mixed properly. Okay, they are not mixed properly, like say oil and water. So different components can be seen by our naked eye. So we can define phase, we can distinguish. It consists of distinct phase. We can differentiate the phase, distinct phase. Okay, and the observed properties are just some of the properties of the individual phases. Okay, homogeneous mixtures, we know alcohol, water, like that. We cannot distinguish the different components present in the solutions. Okay, so it is a single phase which has the properties that may differ from one of the individual components. Okay, so like say alcohol, water, so that is the sugar solution homogeneous components. Clear? Now you see the solutions. What is solution? The homogeneous mixture is called solutions. The homogeneous mixture of two or more components, composition can be varied within the certain limits such that at least one component is a liquid, is called the solutions. Okay. Now a solvent. What is the solvent? We know in a solution the substance included in the larger and which does the dissolving. Okay, that is the solvent. It is the constituent of the solution which has same physical state as that of the solution and generally present in greater amount than all the other components. Solute, the substance which get dissolved, that is the solute, and it is in the smaller quantity. Okay, the component of solution other than the solvent is called the solute. It may or may not have same physical state. Generally it is in smaller amount. In a sugar syrup, you see the sugar is the solute and water is the solvent. Okay, that normally we denote the water as solvent. So water is termed as solvent due to having same aggregation as the solutions. Next part is I told you that I will discuss about this chapter related why the colligative properties occurs. Like say I'm telling you, when we add salt to the water, then boiling point increases. You will find your mother when boiling the egg. Okay, what happens? Your mother dissolves some salt in that water. Why? So that it becomes boil. It boils quickly. Why? Do you know? So science behind that, when you add the sodium chloride, which is a non-volatile solute, to water, then boiling point of water normally is 100 degrees centigrade, and if you add sodium chloride, which is a non-volatile solute, if you add this water salt to the water, then boiling point of the water, it will be greater than 100 degrees centigrade. Okay, and boil will become very fast. Understands? So that's why when you add sodium chloride, the boiling point increases. So that is the elevation of boiling point. We learned the reason behind is that vapor pressures. Okay, why the boiling point increases? That is because of the vapor pressures. You know what is vapor pressure? That you have to know. Now we see in a closed vessels, when water is there, solvent particle is coming up. That is the what? Vapor. We know vapor. So somewhat if we just take out if you pump out some air, then what will happen? Some more vapor, more water will vaporizes. We see the more water vaporizes here, that 3 or 4 aerosol all are vaporizing, but not coming down. In a closed system, when this one aerosol is there, it's coming down, condensation occurs. So more 3 aerosol over there, more vaporizations. So time will come when the vaporization will come, and same time condensation will occurs. So here in this case, vaporization occurs, condensation occurs. Vaporization occurs, condensation occurs. That means they are in equilibrium state. When the vapor and this solvent is in equilibrium state, then the pressure exerted by the vapor, then the pressure exerted by the vapor, that is the vapor pressures. I hope it is clear. Vapor pressure definition is pressure exerted by the vapor when the vapor is in equilibrium with the solvent, pure solvent. Now this is the definition of vapor pressures. Okay, when you add non-volatile solute to the vapor, to the solvent, then vapor pressure decreases and boiling point increases and freezing point decreases. How boiling point increases, how freezing point decreases, we'll discuss later on. Okay, so that is the colligative properties. The different types of colligative properties are there. Okay, elevation of boiling point, depression of freezing point, osmotic pressures. Okay, we'll discuss later on. Okay, next part is that types of solution. All the 3 states of matter, solid, liquid and gas, may have either solvent or solute. Now binary solution means 2 component solution. In your syllabus in class 12 we have the binary solution, 2 component solutions. Okay, suppose one solute, one solvent. Clear? Then binary solution. If the 2 component solution, one is mole fraction, suppose A and B are the 2 components are there. One is solvent, another is solute. The mole fraction of solute and solvent will be 1. If it is ternary, then also total mole fraction of the solute and solvent will be 1. So binary solution, when a solution composed of only 2 chemical substance, it is termed as binary solution. The 3 components is ternary and 4 components are quaternary. For a given solution, the amount of solid dissolved per unit volume of solution is called the concentration. Concentration is very, very important, that I am coming. Concentration of the solution containing relatively high concentration of solute. Concentration means amount of substance present in a certain volume of solutions. Okay, that is very, very important part. Now these terms, you see, dilute solution means containing relatively low concentration depending on the state of solute and solvent and binary solution can be classified as this. We say different solution are there. We have learned in lower class 8 and 9 level. So here we are just giving some example of gas solution, liquid gas solutions, solid solution also is alloy. Alloy is an example of solid solution. Different types of solution I am giving shortly over here. In case of gaseous, this is the types of solutions: gaseous solution, liquid solution, solid solution. One solute, one solvent, and common example I am giving one so that you can understand better. Okay, so what is the gas? What here is a gas mixtures. Okay, it's very common things. Okay, mixture of oxygen and nitrogen in air. Liquid gas, chloroform mixed with the nitrogens. Okay, liquid gas mixtures. Aerated drinks, cold drinks. In the cold drinks, when you open the lid of the cold drinks, some carbon dioxide gas coming out, because in carbon dioxide gas is kept in high pressures. So that is the what? That is the aerated drinks. Okay, that is the solubility of the gas in liquid. Okay, so when high pressure gas is kept at high pressures. When the pressure is decreased, the gas come out. Then solid and gas, camphor in nitrogen gas. Okay, then gas and liquid, oxygen dissolved in water, liquid, ethanol dissolved in water. In corona times, what sanitizer we are using, still we are using. Okay, so sanitizer, what happened? Ethyl alcohol in different percentage is kept in the water. Okay, so that actually clean the germs. Okay, so that is the what? Ethanol dissolved in water, that is the sanitization. Okay, so solid liquid, glucose dissolved in water, gas solid. Okay, solution of hydrogen in palladium. When you convert the hydrogenations, suppose the convert the alkene to alkane or alkyne to alkanes, so we use the palladium hydrogen, nickel hydrogen, etc. In the palladium hydrogen has the highest occlusion process, means the highest occlusion property. Hydrogen gas, when kept in the metal palladium, it outside the metal palladium, hydrogen gas is adsorbed. ADSORPTION, adsorption. So hydrogen gas is kept on the surface of the palladium. Okay, so that is the adsorption. When you heat it, then hydrogen, okay, so unsaturated hydrogen is released and unsaturated compound becomes saturated. That we know it, that is the occlusion process. So liquid in solid, amalgam, mercury, sodium, very active metals. Okay, so sodium is kept in mercury so that its activity decreases and it reacts with the sodium, amalgam and HCl. It reacts. Okay, solid mixture, copper dissolved in the gold or any alloy. Okay, that is the what? Solid mixtures. Very important part. This is the common example. Now let us discuss about the methods of expressing the strength of solution or the concentrations. Strength of solution is the amount of solute in grams dissolved per liter of the solution. It is generally expressed in gram per liter. Other method of expressing the concentration of solutions, I am giving one by one. That is the percentage strength. Percentage means out of 100. Okay, so I am just giving percentage strength out of 100. Weight by weight percentage. Weight by weight percentage. This means weight of solute by weight of solution into 100. Weight of solute, weight of solution into 100. Okay, so this is the weight by weights percentage. So it may be the weight of solvent by weight of solution into 100. Okay, next page you can write. It is the one example let us give, or here we can give, no, is better. One example, 5% NOH weight by weight percentage means 100 gram NaH solution contain 5 gram NaOH. 100 gram NaOH solution contain 5 gram NaOH. That means NaOH solution normally consider the solvent water. Okay, so 5 gram NaOH. Therefore, what you can say? So solvent means here water is what? 100 minus 5, that is 95 gram. I think it is clear. If it is solute mass percentage, and for solute it is okay, it might the percentage of solvent, then it will be the mass percentage of solvent. That means weight of solvent by weight of solution into 100. So it can be weight by weight percentage. Number 2 is weight by volume percentage. Weight by volume percentage. That is W by V percentage. This is equal to weight of solute by volume of solutions. This is equal to weight of solute by, below it is volume, so it should be volume of solution into 100. One example I am giving. Example is giving 5% NaOH weight by volume percentage, means this means 100 cc. Here it was 100 gram weight by weight. Here it is 100 cc NaOH solution. NaOH solution contain 5 gram NaOH. 5 gram NaOH. I hope it is clear. Here weight by volume 100 cc. Here it was weight by weight 100 gram. Okay. Now it is clear. Now third portion is the volume by volume percentage. Volume by volume percentage. Keep in mind, when weight by volume, one is solid, another is solution, liquid. So volume by volume percentage, then both are in liquid states like ethyl alcohol and water. So V by V percentage means volume of solute like say ethyl alcohol or methyl alcohol, and volume of solution. Volume of solution means alcohol plus water into 100. One example we can give, that is 5% ethyl alcohol solutions. Ethyl alcohol solution means 100 cc ethyl alcohol solution. Ethyl alcohol solution contain 5 cc ethyl alcohol. Okay, that means 100 cc ethyl alcohol solution, 100 cc ethyl alcohol plus water, out of that 5 cc ethyl alcohol, and 100 minus 95, 100 minus 5, that is the 95 cc water. I think it is clear. So this is the percentage. Percentage strength, I told you, first weight by weight percentage, weight of solute by weight of solution into 100. It may be the weight of solvent by weight of solution into 100. So that already told you, weight of solvent by weight of solution into 100. Weight by volume percentage, already giving example. And then it is the volume by volume percentage, that is the volume of solute by volume of solution into 100. One example already giving. So this is the weight percentage. Then one of the important concentration terms, that is the molarity. Then we have the molality. Then we have the mole fraction. This is the three very important part. So number 1 done. Number 2, that is the molarity. Molarity I denote M dash to distinguish the molecular weight of solvent, that normally denoted by M. I am giving M dash. What is molarity? In 1 liter, if 1 mole is present, that is the 1 molar solutions. Okay. So here definition is number of moles of solute, number of moles of solute present per liter of solution, per liter of solution is called molarity, M dash. Therefore molarity is equal to number of moles by volume. We can write the unit moles liter inverse. Number of moles is equal to mass by molecular weight, and if we express volume in cc, and then it will be the 1000. So we can write molarity is equal to this. Normally we write this formula where N is equal to W by M. W is the mass of solute, and M is the molecular weight of solute. N is the number of moles. This is the number of moles of solute. Where V is the volume of solution, So since molarity, since the molarity depends on volume changes with temperature, and we can say molarity also it will change with the temperatures. So molarity will change with temperatures. Molarity changes with temperatures. So this is the one of the formula molarity. And if we write in terms of density, then another definition of molarity we can write. Molarity also we can write percentage strength into density into 10 by molecular weight of solute. So that is another definitions of molarity when percentage and density is giving is the density of solution. Significance of the symbol is very important. What symbol you are using, that you must write. D is the density of the solutions. Now after molarity I will discuss the numericals also. Okay. After the molarity, it is the number 3, it is the molality. Then we will discuss the mole fraction. If molality I denote by small m dash. Molality is the number of moles of solute present per kilogram of solvent. Okay. Clear? So definition is number of moles of solute present per kilogram solvent. Is very important terms. Previously I told you molarity is the number of moles of solute present per liter of solutions. So this is not the liter of solution, this is the per kilogram of solvent. Okay, not solution, per kilogram of solvent. It's very important. All are in all concentration terms in solution, but it is the molarity which in per kilogram per kg of solvent. It is very important. It's called molarity. Therefore, molarity m dash, small m is the molecular weight of solute. To distinguish, I am writing m dash, that is equal to number of moles per kilogram of solvent. Okay, per kilogram of solvent, moles kg inverse. So therefore, molarity I am writing W by M into W. When you write in gram, then we express in this manner, where small w is the weight of solute, and small m is the molecular weight of solute, and W is the weight of solvent, not solution. Okay, weight of solvent. Okay, so this is very important. Unit is moles per kg. So this is the molarity. Molarity depends on mass, so that's why molarity does not change with temperatures. Okay, mass does not change with temperatures. So therefore you can write molarity does not change with temperature, independent of temperature, does not change with temperature. This is very important part. Molarity and mole fraction do not change with temperature, but normality and molarity change with temperatures because they depend on volume. The next part is the mole fractions. Mole fraction we denote by x or alpha. What is mole fraction? Is the fraction of moles of solute or fraction of moles of solvent. Okay, so mole fraction you can write fraction of moles of solute or solvent. Okay, that means it is the individual moles of solute by total moles of solute and solvent. Okay, so if you consider mole fraction of solute, like say solute and number of moles of solute solvent, number of moles of solvent capital N. Therefore total moles is coming what? Total moles is coming N plus N. So we can write like this: A and B moles solvent, B moles small n, moles capital N, total moles n plus n. Therefore, we can write mole fraction of A is equal to what? Mole fraction of A is equal to XA individual moles by total moles, and mole fraction of B XB individual moles by total moles, and therefore we can write XA plus XB is equal to n by n plus 1 plus n by n plus 1, that is equal to 1. So total mole fraction is coming 1 whether it is binary components or ternary components. Total mole fraction is equal to 1. XA is equal to 1 minus XB. You can write this one. Suppose glucose has mole fraction 0.2 and therefore mole fraction of water is 1 minus 0.2, that is the 0.8. So like this we can write. This is the molarity and mole fractions. There are some relations we have. The relation between the molarity and mole fraction that I am discussing along with some numericals. Okay, and normality another terms is there. Normality another terms is there. লস্কর একটু কাটতে শোনো, লস্কর একটা দিয়ে দেবে, লস্কর একটু কাট বলছি, ওই এখন পেজ দিয়ে দেবে একটা। Now already we have discussed the mole fractions. The mole fraction is the fraction of moles of solute or solvent. That means it is the individual moles of solute or individual moles of solvent. Total mole fraction of a component, two components, is equal to XA plus XB, that is coming 1. Mole fraction also does not change its temperatures. Okay, keep in mind mole fraction X does not changes with temperature, does not change with temperature because it depends on the mass and does not depend on the volume. After mole fraction, it is the one definition I am giving, normality, and then I will give the relations. Normality we have learned in class 9, class 11, also in 9 also. Normality means if 1 liter 1 gram equivalent weight of solid present, then it is called 1 normal. So we can say number of gram equivalent weight of solute present per liter of solution, present per liter of solutions. Per liter of solution is called normality. Normality I denote capital N dash. Okay, and therefore normality N dash is equal to W by E into V in volume in liter. So gram equivalent liter inverse, where W is equal to weight of solute, and E is equal to equivalent weight of solute, which is equal to molecular weight of solute by N factor. N factor is the valence factor, that you know, number of cations or anions for salt. It is the number of H plus ion, but basicity of the acid for acid, and for base it is the acidity of the base. So that we know E is the equivalent weight of solute and V is the volume of solutions. V is the volume of solutions. Now if I write in terms of solution means ml, liter converted into ml, then it will be E into V in cc or ml into 1000. So this is the nominality in terms of cc, volume in cc. Now when two solutions are mixed, N1 V1, okay, is equal to acid, but means acid base mixtures, that we know it, that is the defined part we have already learned, okay, in class 11. So normality also depends on temperatures. Normality depends on temperatures or changes with temperature, depends on temperature, because it is depend on volume change with temperatures. Clear? For acid base solutions, already we have learned N1 V1 for acid for normality is equal to N2 V2 of acid base for neutralization reaction, that we know it, we have learned in class 11, okay, for neutralization reactions, for neutralization reaction. Neutralization reactions. Now, what is the relation between the normality and molarity? This relation is very, very important. What is the relation of normality molarity, molarity molality, and molality mole fractions? These three relation is very, very important. That I am coming. The relations are, number one, normality is equal to, is very, very important, N factor or valence factor into molarity. These very, very important relations. Number two relation is density of the solutions. Density of the solution, small d, is equal to molarity into 1 by molality plus m by 1000. So this is also important relations. This how this means relation comes, that is your homeworks I am giving, dear students. How will get this one? We are learning probably in class 11. So once again, find the relations between the density, molarity and molality. This find your relation, that is your homeworks, okay, and will send me in my email, I will give you in the last, okay. So where D is the density of the solution, significance you know, D is the density of the solution, I told you, density of solutions, solution. What is M dash? M dash is the molarity. What is small m dash? That is the molality. What is the M? M is the molecular weight of solute. So different significance of the symbol, very, very important. What are the different significance of the symbol, that is important. Number three, relation between the molality and mole fractions. So molality, small m dash is equal to XA by XB into MB into 1000. So this is the relation between the molality and mole fractions. Relation between molality and mole fractions. Here we have one numericals, I am giving next page, okay. What is XA? XA is the mole fraction of solute. Mole fraction of solute. How it comes, you will derive and you send me. XB is equal to mole fraction of solvent, solute, solvent. MB is the molecular weight of solvent. For water, it is 18, that we know. So this is the relation. These are very, very important relations. All these three are very, very important relations, okay. And for normality molarity conversion I am giving, Okay, normality of mixing, molarity of mixing you have learned in class 11. That I am not discussing. Now let us do some numericals, very simple numericals. Okay, what is the molarity of 4.9% H3O4 solution by mass density of H3O4 is giving? So percentage, what is giving? Molarity of, we have to find out, percentage giving, and the density is giving, density. So density we have the one relations, we know the molarity, the relation, if the density and percentage strength is giving, that we can find percentage strength into density into 10 by molecular weight of solute. We know the molecular weight of H3SO4. What is that molecular weight of H3O4? H3O4, that is the hydrogen 3 into 1 plus phosphorus 31 plus 4 into 64. 4 into 16, that is the 64. 3 plus 31 plus 64. It is 98. Okay. So H3SO4 molecular weight 98. Now percentage strength is giving 4.9 into density is giving 1.22. It is giving 1.22. Okay. And 10, formula 10, and it is the 98. Now point is omit point, 10 cancel out, 49 2, and it will be divide this is on 2.61. 0.61 is there, 0.61 molarity. So this is the option number 1 is correct. I hope it is clear. Simple. Then numerical number 2. The molarity of 1 molar in NO3 solution density is giving. How will do this one? Very difficult to do unless you know these relations, unless you know these relations. Here molarity is giving, density is giving, and you have to find out the molarity. And NaNO3 molecular weight is giving. So this formula is required. Density of the solutions, D is equal to m dash by 1 by m dash plus m by 1000. This relation is required. You see what is giving? Molarity is giving 1 molar, density is giving, okay, and NaNO3 solution, molecular weight of NaNO3, that is m is equal to what? Sodium 23 plus nitrogen 14 plus 3 into 16, 48, that is 85. Okay, 85 is coming. So this we know, therefore it is 1.25 is equal to 1 molar, 1 by m dash, and is 85 by 1000. So how will calculate easily? 1.25 is equal to 1 by m dash plus 0.085. Now you just 1 by m dash is equal to 1.25 minus 0.085. Okay, this is coming. It is 1.16. Therefore m dash is equal to 1 by 1.165, that is equal to 1000 by 1165. That will come, you just do, I remember this one. Okay, it will come 8.58 something, it will come. Okay, so is option number B. This question came in IIT. Okay, so this is how we can calculate easily, understands, without doing any much complications. Simplest way we can write this one. Okay, so if you know this formula, we can do this numerical within 1 minute, understands. So this is how we have to do the numerical shortly. Which formula we'll use, that is very, very important. Unless you know this formula, these relations, we cannot do easily. Okay, otherwise very difficult. Difficulties. It is the IIT questions. And students, I told you this relation how will find out. You have learned in class 11. Once again, you just send me in my this. Okay, another numerical is there. Okay, you will send it in my email. Another numerical is there. Okay, let us do complete this one, then I will complete it. Calculate the molarity of an aqueous solution of glucose having mole fraction 0.2. What is giving? Molality you have to find out. Aqueous solution of glucose means glucose dissolved in water. Aqua means water. And having mole fraction of glucose is 0.2. That means the relation we have learned, molality m dash is equal to xa by xb into mb into 1000. Here what is giving? Here we have xa is equal to what? Xa is equal to mole fraction of glucose, that is giving 0.2. Therefore xb is equal to what? 1 minus 0.2, that is the 0.8. Clear? And aqueous solution means water molecular weight. Molecular weight is equal to what? Molecular water, that you know 18. Okay. So therefore molality you have to find out. This is the 0.2 by 0.8 into 18 into 1000. So point cancel out, 4 250, 250 by, that is the 125 by this 9. Okay. So this is 9, 1 is 9. Okay. 3 13.8 something it will come. Option number C is correct, 13.8. So it is also very important. Unless you know this relation, it is very difficult to do the numericals. Okay. So this is how we can do the numerical easily. This is also important questions. Okay. And it came in competition level. Clear? Now I am ending the session over here. And what about the question I have told you? Okay. Please send it in my mail. Okay. BADARUDDINA@TIGPS.in. And you also, if you have any doubt while I have taught any portion doubt, you can send it in my mail. I will answer it in the next class. Okay. And for the time being, I am ending the sessions. Thank you all. I am ending the session over here. Again, next lecture 2, next class I will do it. Thank you so much.